am Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this lecture, we are going to discuss about addressing modes of 8086 microprocessor. Here, the importance of addressing modes are while writing the assembly language program, addressing modes instruction set plays the major role. Here in 8086 microprocessor, we are going to write the programming assembly level language programming. So this assembly level language programming is a low level language programming. So low level language means this is the language that can be easily communicating with a computer hardware. So here this assembly level language programming we are going to write with the help of mnemonics and registers. Here, before going to the addressing modes of 8086 classification, first we have to see what is meant by addressing mode, what is meant by opcode and operand, how they are allocated in the instruction format, and how many addressing modes are there here. So, addressing mode indicates a way of locating data or operands. So, it means in how many ways the operand can be accessed. And the addressing modes describe the type of operands and the way they are accessed for executing an instruction. So, here we can have many ways in order to access the operands. So, it will be varying from addressing mode to addressing mode. And so according to the flow of instruction, the instructions will be classified into different types. So generally here, the instructions will be executing in different manner. So in how many ways the instructions can be executed means, here the execution may be of sequential control flow, or the instructions may be executed with the help of control transfer instructions. So we will discuss in detail what is meant by sequential control flow and what is meant by control transfer instructions. And also we will see what are different addressing modes that comes under sequential control flow instructions and what are different addressing modes that are coming under control transfer instructions. Next. So, before going to the discussion and examples of addressing modes, first we will see the general example how the addressing modes will be related to. So, suppose if you take one example. So, here consider this is a gift and this gift you are going to give to your friend. So, generally coming to the technical concept, here the watch can be considered as source or you can consider it as operand, and whereas here the gift to where it has to reach, that is to the friend. Here this friend can be considered as a destination. Now, so seeing this example, we can say here the gift, whatever we want to give to a person can be sent in different ways. So here in this case, the gift can be directly given to a person. That means here the operand can be directly sent to the destination, which we can call as immediate addressing mode, or the same gift in another case. If you see here, this is another case. Now, so here the same gift can be sent to your friend in another way, like taking the gift, putting in the gift box, that means packing it, and then it is going to give it to a friend. This is another way of sending a gift from source to the destination. That means here, if you go to the technical concept again, so considering it as an operand. This operand can send from source to the destination by using some register. Now, in another case, if you see here, the same gift you are sending to the destination, that is friend, in another way. Like here, so taking this gift, packing it into a gift box, that gift box sending it through a courier boy, and this courier boy is going to give that gift to a person. Like this here, based on the simple example, we can understand that the gift can be reached to a person in different ways. In the same way, the operand can be sent to the destination in different ways. So in how many ways we can send the operand from source to the destination says these types of addressing modes. Now, so coming to the way, how many ways the instruction can be executed means, so here sequential control flow execution, and next one is control transfer instruction. So in these two ways the instruction can be executed. Suppose, so if you take here the first case, sequential control flow instructions. So if you take the first case, sequential control flow instruction. So in this case, we should know how the instructions will be executed. So if it is a sequential control flow, the name itself says that all the instructions will be executed in the sequential order. That means here, so for example, in the program, if it consists of some 5 instructions, like this is the first instruction, and consider this is the second instruction, and here third instruction, and consider this is the fourth instruction and fifth instruction. So if your program consists of 5 instructions, for example, if it is sequential control flow instruction, the control flow, that means the processor will be executing instructions in the sequential order. Sequential order means, so initially it is going to execute the first instruction, then it executes the second instruction, then only it goes to the third instruction. So sequential control flow instruction means the instruction will be executed in the sequential order. If one instruction is executed, the instruction that is immediately placed after that will be executed in the next cycle. So this type of sequential execution of instructions are called sequential control flow instructions. And the second classification here is control transfer instructions. Control transfer instructions. So here the name itself says the control will be transferred. The control will be transferred to some predefined address, or we can say the control will be transferring to the specified address in the program. So here, for example, in the control transfer instruction, suppose if you have the first instruction and if you have the second instruction, and then you have the instruction like call, suppose 5000, or another instruction like jump 6000. So if such a type of instructions executes in between, the control will be transferring to some predefined address. And here whatever the address we are specifying in these two cases, they are called the predefined address, or the address what you are specified in the program. So how the processor is going to execute the instructions in this case means, so initially it is going to execute the first instruction, then the next instruction will be executed. So if such a type of instructions are there in the program, next here, after executing this call or jump instruction, the remaining instructions here will not be executed. So it is going to some predefined address where the instructions have been written in order to perform a specific task. This is the difference between sequential control flow and control transfer instructions. So after executing this program, then again the control will be coming to the main program and it executes the remaining lines in the main program in the sequential order. Now, so here generally addressing modes means in how many ways the operand can be accessed. So generally here we can see the general format of an instruction. So if you see here instruction format, so generally the instruction format consists of two parts. So here the two parts are, one is called opcode, another one is operand. Here in place of opcode we are going to write mnemonics. In place of operand, you can use here, like you can indicate memory locations, or you can indicate here registers, or you can have here some input data. So this is the general format of an instruction. So first we have to know here what is meant by opcode. So opcode indicates the type of operation that the processor is going to perform. Like suppose in place of this opcode, you can write here move, or you can write here add, or you can write here mul, or and. So here the opcode represents the type of operation that should be performed. And here operand. So here what is meant by operand means, operand here opcode, it is going to do the operation. On what it is going to do this particular operation means operand says that. So operands indicates on what data it is going to perform the operation. So this operand column includes either memory locations or registers or any immediate data. Now here this is another format, instruction format. So if you are going for 16-bit instruction, how these 16 bits will be divided in the instruction format. So here in this opcode, it consists of 4 bits. The operand part consists of 6 bits and 6 bits. So totally here 16 bits. So this is another way of representing 16-bit instruction format. And so here as we have discussed, what is meant by sequential control flow instructions? The control flow, that means the processor will be executing the instructions in the sequential order. That means one instruction after another instruction. So that is the instruction placed immediately after each instruction will be executed automatically. Now, here sequential control flow instructions are the instructions which after execution the control will be transferring to the next instruction which is appearing immediately after that. That means all the instructions will be executed in the sequential order in the program. Now, so here in order to execute the instructions in the sequential order, compulsory while indicating the opcode in the instruction format, it should include only arithmetic, logical or data transfer instructions. So here what all the arithmetic instructions will include. So you can write in the addressing mode in place of mnemonic as arithmetic like add, subtract, and logical operations, logical instructions you can use like and, or, not, and also you can use some data transfer instructions in order to execute the instructions in the sequential order. So the data transfer instructions includes move, exchange, like push. So all these are different instructions we can use in order to execute instructions in the sequential order. So that is why here we have to use in the sequential order only arithmetic instructions, logical instructions and data transfer instructions. So in order to maintain the sequential control flow during execution of instructions. Now, here, what are all the addressing modes that comes under sequential control flow instructions? So we have a classification of addressing modes, different types are there. Now we need to know what are different addressing modes that comes under sequential control flow and what are different addressing modes that comes under control transfer. So now coming to the sequential control flow, the first addressing mode is here immediate addressing mode, and next direct addressing mode. Next, here register addressing mode, and next addressing mode register indirect addressing mode, and next indexed addressing mode, and register relative addressing mode, based indexed addressing mode, and next one is relative based index addressing mode. So all these are different types of addressing modes that comes under sequential control flow instruction. So we have to keep in mind, so while writing or while considering the examples of all these addressing modes, in order to represent an example, compulsory, since all these are coming under sequential control flow, we have to explain this addressing modes, and example should include in the mnemonic part, like either data transfer instruction, arithmetic instruction, or logical instructions. Now, so coming to here, control transfer instructions. So control transfer instructions means here the control will be transferring to some predefined address or the address that is specified in the program. Here the instructions will not be executed in the sequential order. Now, so the control transfer instructions, after transfer control to the some predefined address or the address which you have specified in the instruction. After execution of the instruction, like if you use call some predefined address or jump predefined address, the control will be moving to that specified address in the program when such type of instructions are executed. So we have to write the examples under this control transfer instructions by using the instructions like jump, call, return, like that. Now see here, while writing the control transfer instructions, we have to use int, call, return, jump instructions. Now we will see what are different addressing modes that comes under this control transfer instructions. So here are some addressing modes. So intersegment and intrasegment. These two are the addressing modes that comes under control transfer instructions. So here what is meant by intersegment? Intersegment. So intersegment means the meaning is out of the segment. That means here the predefined address what you are specifying in the instruction, that address will be present in the another segment. And so in this intersegment addressing modes, you have two categories like intersegment direct and intersegment indirect. And another type is here intrasegment addressing mode. So here generally the meaning of intrasegment means within the segment. That means here the predefined address what we are specifying in the instruction, that address will be present within the segment. So such type will come under intrasegment addressing modes. So again in the intrasegment addressing modes, we have direct and indirect. So this is the classification of addressing modes that are coming under sequential control flow and control transfer instructions. So now we will discuss about each addressing mode in detail. Now first we will see about sequential control flow instructions. Now the first sequential control flow instruction is immediate addressing mode. So the name of the addressing mode says the operation here. See, this is immediate addressing mode. That means immediate data will be specified as a part of an instruction. That means the operand can be directly sent into a register or any other memory location. Immediate addressing mode. Immediate data will be specified as a part of an instruction. So here in the addressing modes, generally what is important means what we are specifying as a part of an instruction is the major thing. So if you consider here immediate addressing mode, immediate data is specified as a part of an instruction. So here since we are seeing all the sequential control flow instructions, for each addressing mode, we will discuss example. That examples will contain only the instructions like arithmetic, logical or data transfer instructions only. So here first see what is meant by immediate addressing mode. So in this type of addressing mode, immediate data will be a part of an instruction. Now, so if you consider here, this is an example, move AX, 1, 2, 3, 4, H. Okay, so this 1, 2, 3, 4, H, it is a 16-bit number. So generally, based on the instruction format, so this is called mnemonic. Soon after mnemonic, we are going to consider this as destination area, and this area is called source area. So since it is immediate addressing mode, this is the immediate data. This is the immediate data which is specified as a part of an instruction. So here if we consider this data, it is of 16-bit. So here the size of the data is 16-bit. That is why here the size of the register should also be of 16-bit. So here we have considered AX. It is a 16-bit register. So here move is the instruction that comes under data transfer. Move AX, 1, 2, 3, 4, H. So what is the operation here means? This 1, 2, 3, 4, H, it is a 16-bit data. That 16-bit data will be moved into AX register. So here we have to keep in mind that whatever the size of the source we are taking, the size of the destination also should be of source size only. Then only the data will be able to fit in the destination. So here we have considered 16-bit. That is why destination register is also of 16-bit register. Next. So another example if you take here, move BL, 16H. So this 16H if you take, it is a 8-bit number. It is an 8-bit number. So if we consider here, this is an 8-bit number. That is why here the destination is BL, not BX. BL is a 8-bit register. So this 16, it is an immediate data which is specified as a part of an instruction. So this 16 will be moved into BL register. 16 is an immediate data here. Now, so here in the above example, the immediate data will be moved into all the required registers. And next addressing mode is direct addressing mode. So here in the direct addressing mode, so what will be specified as a part of an instruction? Like, so here if you see, in the direct addressing mode, a 16-bit memory address will be specified as a part of an instruction. That means address will be specified directly. Address will be specified directly as a part of an instruction. So in the part of the instruction, the address whatever we are specifying, that address is nothing but offset address. We have already studied what is meant by segment address and what is meant by offset address. But in this case, direct addressing mode, whatever the address we are specifying as a part of an instruction, that address will be considered as a offset address. Here, offset address will be specified directly as a part of an instruction. So if you see here, this is an example, move AX, 5000H. So if we see here, this 5000H, it is kept in the brackets here. So if that value is kept in the bracket, it represents that it is a memory address. If this 5000H is not kept in the brackets, if you are writing like simply move AX, 5000H, this 5000H will become the immediate data again, not the address. Okay, but in order to specify direct addressing mode, now, so in order to specify here the direct addressing mode, compulsory you have to specify offset address as a part of an instruction. Here, the operand will be resided in this address. The data which is present in this 5000H location, memory address, will be moved into AX register. Now, here we have seen the data that is going to reside in the memory location in the data segment, whose effective address may be computed by using 5000H. So this 5000H is the offset address. While calculating the effective address, you have to consider the segment address also. So in this direct addressing mode, you have to consider the type of the segment as data segment. So considering this offset address and segment address, the effective address will be calculated. The physical address will be calculated. Now, so see here, how to calculate the effective address. So this effective address can also be called as physical address. So physical address size may be of 20 bit because the address bus size available in 8086 microprocessor is 20 bit. So if you see here the effective address, this is segment address into 10 plus offset address. So why it is here 5000H? This is the offset address, what you have specified in the considered example. Now, next addressing mode is register addressing mode. So here, see the name here, register addressing mode. It means register will be specified as a part of an instruction. The operand will be resided in the register. Now, so in the register addressing mode, the data will be stored in a register and it is referred by using particular register. So all the registers we can use, but except instruction pointer in this register addressing mode. So whatever the registers are available, we have seen that there are 16-bit registers available in 8086 microprocessor. So in order to represent this register addressing mode, we can use any of the registers, but except the instruction pointer. Here, this example can be considered as register addressing mode. Here, register is specified as a part of an instruction. So move BX, AX. So here, this area is called source and this area is called destination. So the source and destination includes the operand part, whereas move instruction will be including in the opcode part in the instruction format. Here move BX, AX means the data that is available in AX or the operand that is available in AX register will be moved into BX register. So here also if you see the size of both the registers, that means the size of the source register is 16-bit and also destination register is 16-bit. Now, so another example here we have considered is ADC, AL, BL. So here both the registers are 8-bit registers. ADC means add with carry. So here we have used the data transfer instruction and here you have used the arithmetic instruction. So as we have already discussed, under sequential control flow instructions, you can use either data transfer or arithmetic and logical instructions. Now, so here in this case, the operand can be stored in AX register, BX register, AL and BL registers. And next addressing mode is register indirect addressing mode. So if we see the name here, register indirect addressing mode. Register is specified as a part of an instruction, but it will be specified indirectly. Register will be specified as a part of an instruction, but it will be specified indirectly. So indirect representation means again that register keeping it in some address or memory location. Such a type of representation we call as register indirect addressing mode. So here the address of the memory location which contains data or operands, that will be specified in the indirect way using any of the offset registers. Now, so here in this addressing mode, we can specify offset address. But that offset address you have to include only in some registers like BX register, SI or DI registers only. So if you are having the offset address in any of these registers, we know the offset address will be getting from any of the pointer registers, index registers or base registers. But in the register indirect addressing mode, we can consider the offset address only from base register or index registers SI or DI. And another one is, what about the segment address? So if it is register indirect addressing mode, you have to consider the segment address that is coming from DS or ES, data segment or extra segment. So based on this offset address and segment address, the effective address can be calculated. Here, now see here the example, move AX, BX. Register is specified as a part of an instruction, but it is specified indirectly, keeping it in the bracket. That means keeping it in some memory location. Now, so the data which is present in the memory location specified with this register will be moved into AX register. The data is present in the memory location DS, whose offset address is specified with the help of a register BX. Now, so in order to calculate the effective address, that is physical address, 20-bit physical address, you have to consider the segment address and offset address. So segment address from any of the segment registers and offset address from BX, SI or DI registers. So based on the considered example here, segment address into 10 plus offset address. Why? Because here in the example, the offset address here you have considered with the help of BX register. Now, so next addressing mode is indexed addressing mode. So here the name itself says indexed addressing mode. That means index register will be specified as a part of an instruction. So as we know here, index registers in 8086 microprocessor, two index registers are available. One is SI, that is source index. Another one is DI, destination index. So here you can use SI or DI in this addressing mode. So that is why here indexed addressing mode. Index register will be specified as a part of an instruction. That is either SI or DI can be represented as a part of an instruction. Now, so in this addressing mode, offset of the operand is stored in any of the index registers. So here we have in 8086 microprocessor, two index registers. One is SI, source index. Another one is DI, destination index register. Anyway, from this SI and DI registers, we are going to get the offset address. But what about the segment address? In order to calculate the physical address of an instruction, we need segment address also. So if it is index addressing mode, we have to consider the segment address from DS and ES. That is data segment or extra segment can be considered in order to find the segment address. Now, so if you see the example here, move AX, SI. So SI is kept in the brackets here. Okay. So here this SI. So SI represents source index. So here index register is specified as a part of an instruction. So that is why it is coming under indexed addressing mode. Even this addressing mode comes under sequential control flow. So in the sequential control flow, in this example, we have used data transfer instruction. And next, move CX, DI. And another index register available in 8086 microprocessor is DI register, destination index register. So even we can use this register also as a part of an instruction. So both these are index registers. So these two comes under the examples of index addressing mode, because in these two cases, index registers are specified as a part of an instruction. So this index registers only will be carrying the offset address. So since it is address, in order to say that it is address, we are keeping this registers in the brackets here, which represents the memory location. Now, so here the data is available at the offset address in SI, and the segment address you have to consider is DS. So in these cases, if these are the examples, we will see now how to calculate the effective address, that is 20-bit physical address. So here, as we know the formula, segment address into 10 plus offset address. So here segment address we are getting from the data segment, and the offset address we are getting from the source index. And this is another one. Why? Because here two examples we have considered. So move CX, DI. This is another index register which is carrying the offset address here also. So segment address into 10 plus offset address. And next addressing mode is register relative addressing mode. So in this register relative addressing mode, so see the name here, register relative addressing mode. So register will be specified as a part of an instruction. Not only register, to that register you will have relative. So here relative here is nothing but displacement. Displacement. Okay. So here along with a register in the part of an instruction, we will also have some displacement to that register. So it comes under register relative addressing mode. Register along with the displacement will be specified as a part of an instruction. So that register along with the displacement, totally we are going to get the offset address from that two registers and displacement. Offset address will be given, and we have to consider the segment address in order to calculate the effective address. And so if you see here in this addressing mode, that is register relative addressing mode, the data is available at the effective address by adding 8-bit or 16-bit displacement. So as I told you here, the word relative represents here displacement. So the displacement may be either 8-bit displacement or 16-bit displacement. With what it is going to displace? With the help of registers. To these registers, they are going to do the displacement. So you can consider here the registers like BX register, base pointer, source index, and destination index. So all these registers you can use, and to these registers you can have some 6-bit or 16-bit or 8-bit displacement. So totally we are going to get the offset address from this, and anyway by default we will get the segment address from data segment and extra segment in case of this register relative addressing mode. Now, so here this is the example of register relative addressing mode. See here, this is the register and here this is the relative. So register along with displacement is specified as a part of an instruction. So this 50H along with the location of BX will be giving you the offset address. And here segment address anyway you have to get from any of the segment registers like DS or ES. And next, if you see this example, move 10H SI, and here it is DX. So here if you see, this is the index register and this is the displacement. So these two together gives us the offset address. And in this register addressing mode comes under sequential control flow. Hence here only data transfer instructions are used. Now, so in this case, how to calculate the effective address? So if you consider here the first case. So segment address either from DS or ES. So here segment address into 10 plus this is the offset address. So totally we will get a 20-bit physical address. So if you consider here the second example, segment address into 10 plus this is the offset address in the second case. Why? Because here 10H SI. Now, so next addressing mode is here based index addressing mode. So here we can see the name itself says based indexed. That means as a part of an instruction, we will have base register and also index register. So what is meant by base register? Base register is BX. And index register, two index registers are there. So you will have SI or DI. So base register along with index register will be represented as a part of an instruction. So it comes under based indexed addressing mode. Now, so whatever we are indicating with the help of this BX and SI, that together will give us the offset address. And anyway, we have to consider the segment address from either ES or DS, that is from data segment or extra segment. So in this case here, you have any of the base register. So BX is base register and BP is called base pointer, and any of the index registers like SI or DI. So these gives us the offset address, and the segment address will be calculated from the segment register. So in this based index addressing mode, the segment registers what we have to use is either ES or DS. Now, so you can consider this example as a based index addressing mode. So this based index addressing mode comes under sequential control flow. So that is why here only data transfer or arithmetic or logical, only those instructions should be used to represent this addressing mode. Here if you see based index addressing mode. So here base and index registers are specified as a part of an instruction. So here BX is a base register and SI is a index register. So these two together will give the offset address. And next, so this is another example you can see. Here in this also base register along with index register is specified as a part of an instruction which gives the offset address. And segment address we have to take from extra segment or data segment. So in order to calculate the effective address for these two cases, so you have to go for, as usual, we know the formula to calculate the 20-bit physical address, that is segment address into 10 plus offset address. Here segment address into 10, that is data segment, and offset address will be from base register and index register. And similarly, for the second case in the example, to calculate the effective address, segment address into 10, and this is going to give the offset address. So this represents here offset address. And the next addressing mode is relative based index addressing mode. So here relative based indexed. So three terms are there. Relative means displacement. So we can have here 8-bit or 16-bit displacement. And here base register. So base register, so you can have BX or BP. And the next index register. So index register you can have here SI or DI. Okay. So here in this type of addressing mode, 8-bit or 16-bit displacement along with base register along with index register will be specified as a part of an instruction. So these three terms together provides the offset address. Now, so in this case, we have to go for using 8-bit or 16-bit displacement. So it says the word relative. And next, that should be added to the contents of base register, because here you have the based term. And for this, you have to also include any of the index registers by default. So the index register may be either SI or DI. So all together gives the offset address. And so if you see here, move AX comma 50H. This is the displacement, 8-bit displacement. And here this BX, it is a base register. And here it is SI, index register. So base register along with index register and displacement. So these three terms will be specified as a part of an instruction. So it comes under relative, based index, addressing mode. So these three terms together gives the offset address. So offset address will be specified as a part of an instruction. But this offset address will be getting from these three terms. That is displacement, base register and index register. Now, so in order to calculate an effective address, so for this example, we have to consider here segment address into 10. In this case also, in order to get the segment address, we have to go for using either data segment or extra segment. So segment address into 10 plus offset address will be getting from these three. So using this, the effective address can be calculated and it will be of 20-bit in size. Now, so this is what about sequential control flow instructions. Now, coming to here, the control transfer instructions. The control transfer instructions means the control will be transferring to some predefined address when such instructions are executed. As we have discussed, what are the addressing modes that comes under control transfer instructions means intersegment and intrasegment addressing modes. So intersegment means the control will be transferring to another segment which is out of the segment. Intrasegment means the control will be transferring to the predefined address within the segment. Now, we will discuss about this control transfer instructions. So in the control transfer instruction addressing modes, here whether the destination location is within the segment or within different segment is the condition. Now, so intersegment. So intersegment means out of the segment. Again, it is classified into intersegment direct and intersegment indirect. So this direct and indirect term represents how that specific address is indicated as a part of an instruction. So if it is indicated directly, it comes under intersegment direct. If it is indicated indirectly, like keeping in some register like that, it comes under intersegment indirect addressing mode. And the next classification is intrasegment. So intrasegment means within the segment. Again, this intrasegment is classified into intrasegment direct and intrasegment indirect. Now, so coming to here, first we will discuss about intersegment direct and then we will go for indirect. First, so intersegment. So as we know, intersegment means out of the segment. Now, so in this addressing mode, the address to which the control is to be transferred will be present in different segment. So if the control is transferring to some other segment, then we will call as intersegment. And where it has to transfer the control, if we are specifying the address in the direct way, that means as a part of an instruction, it comes under intersegment direct mode. So here, branching from one code segment to another code segment. That means from one code segment to another code segment, if the control is going to transfer, it comes under intersegment direct mode. And here the code segment and instruction pointer of the destination address will be specified directly. That means the predefined address where the control has to move, that is the physical address, it will be calculated with the help of this segment address and offset address. Because here segment address will be from the code segment and offset address will be from the pointer register, that is from the instruction pointer register. Now, so if we consider here the example JMP 5000H and 2000H. So here the value of CS and IP is directly represented as a part of an instruction. So here this 5000H says the value of CS, code segment address, and here this 2000H is the offset address. So using these two, effective address can be calculated, that is the physical address where the control has to transfer. Now, so intersegment indirect mode again. So intersegment here again it represents intersegment out of the segment only. And here that specified address will be represented in the indirect manner. So in this mode, the address to which the control is to be transferred will be in the different segment, as we know, because it is intersegment, and that particular segment address will be specified as a part of an instruction, but it will be specified in the indirect manner. Like specifying indirectly means that particular address can be represented with the help of considering any memory block or by using some other addressing modes. Okay, so any addressing mode they can use, but except immediate addressing mode. Why? Because immediate addressing mode means the data will be transferred, not the address. So here this JMP 2000H. So this 2000H, it is the address, but it is specified indirectly. It is specified indirectly. So that is why this address is the intersegment address. So that means this address is the place where the control has to move to some other segment, but it is specified in the indirect manner. So it jumps when this instruction is executed, it is going to jump to the address in the other segment. Now, next addressing mode is intrasegment direct. So intrasegment means within the segment. So here the control will be transferring within the segment, and that segment address will be specified directly as a part of an instruction. Here. So the address to which the control is to be transferred will be lying in the same segment. So that is what intrasegment represents. And in this direct addressing mode, and that particular intrasegment address will be specified directly as a part of an instruction. Now, so here in this addressing mode, the displacement is computed relating to the content of the instruction pointer. Now, so here in this type of addressing mode, generally we will go for 8 or 16-bit displacement. So if we see here, generally this is the instruction format. So jump, short label. So in the place of this short label, we can have here short jump or long jump within the segment. Suppose if the control transferring is within the segment, and if it is in the range in between -28 to +27, in this short label, you can have short jump. Or if the displacement is of 16-bit, you can have here in the short label as long jump. Why? Because here the control, it has the control that should be transferred within the segment. Since it is 16-bit, it will be in the range in between 32,768 to plus 32,767. Based on the range where the control has to transfer, here we have to consider the label as short jump or long jump. Intrasegment means control transferring within the segment. And next one is intrasegment indirect mode. So here also intrasegment means within the segment, but that address will be specified in the indirect manner. Now, so the displacement to which the control is to be transferred will be in the same segment, but that segment address will be specified in the indirect manner. Now, so here this type of addressing mode will be used in unconditional branch instructions. So we have two types of branching instructions, conditional and unconditional branch instructions. So unconditional branch instructions means the branching operation will be performed even though if the condition is not satisfied. So in such cases only this type of addressing mode will be used. So simply like JMP, if you write, that JMP instruction comes under unconditional branch instruction only. Okay. So JNZ, for example, if you write jump if not 0, that jump instruction will comes under conditional branch instruction. We cannot use that conditional branch instruction. We have to use only unconditional branch instruction in order to specify this addressing mode. That is why here simply JMP is used, and the address to where the control has to move within the segment will be specified with the help of this BX register indirectly. So this comes under intrasegment indirect mode. So here the effective address will be stored in BX. So in this session, we have learned about the addressing modes of 8086 microprocessor. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.